All right, problem 8 says to compute the flux of the vector field F, which is yj across the portion of the cylinder x squared plus y squared is equal to 4, where x and y are greater than or equal to 0 and z varies from 0 to 4. And then it says the surface is oriented so that normal vectors point in the general direction of the positive y-axis. All right, so here's a picture of the surface, which is a portion of a quarter cylinder of radius 2 in the first octant. And here's the parameterization, which is just taken from the worksheet. And since the radius of the cylinder is 2, right, A here is just 2. And note that u varies from 0 to pi over 2, because u is just the polar angle theta. And v, which is the z-coordinate, that's varying from 0 to 4. Okay, now when they say that normal vectors point in the general direction of the positive y-axis, well, when determining, say, the rate of flow of a fluid through this surface, we have to make a choice of which direction of flow will be counted as positive and which direction will be counted as negative. So given that the surface is oriented so that normal vectors point in the general direction of the positive y-axis, and our flow vector field F here points in the positive y-axis, right? It's just yj. We are observing, in this case, positive flux, right? So our flux integral will come out to be a positive value. And furthermore, our normal vector down here, which again just comes from the worksheet, so tu cross tv is 2 cos u, 2 sine u, 0. And here I'm just setting a equal to 2 in that expression from the worksheet. And this normal vector, it points outward from our cylinder in the general direction of the positive y-axis. So in other words, it's consistent with this chosen orientation for the surface. Okay, now if let's say the surface was chosen so that normal vectors actually pointed in the general direction of the negative y-axis, okay, if that were the case, then our parameterization would not be consistent, and in that case we would just take the opposite of this vector, so we'd be using these inward pointing normal vectors, okay? Or put another way, okay, if you were to compute the flux integral with, say, this choice of orientation where normal vectors point in the direction of the positive y-axis versus the flux integral with the orientation where normal vectors point in the general direction of the negative y-axis, those two values will be equal but opposite. All right, so now with all of this being said, let's go ahead and set up our integral. Okay, so first off, the vector field F evaluated along our surface S here. This is our F of RUV. Here, I'm just setting y equal to 2 sine u. That just comes from the parameterization. And our vector field F is just yj, right? So 2 sine u will be the j component of F evaluated along the surface. And the I and the k components are just 0. All right. And so then, as we discussed in the last video, the surface integral of our vector field over S here, that can be computed in terms of this parameterization where we're going to take F evaluated along the surface, so this is just the F of R of UV, dotted with this normal vector TU cross TV. All right, and so putting that all in, right, we're going to take the dot product of this blue vector, 0, 2 sine u, 0, with this red vector, 2 cos u, 2 sine u, 0. And we're integrating this dot product in the UV plane, right, over the rectangle where u varies from 0 to pi over 2 and v varies from 0 to 4. Okay, now this dot product is just 4 sine squared of u. And so to integrate this, I want to make use of this identity that sine squared of u is 1 minus cos 2u all over 2. And note here that for the v integral, since the integrand is independent of v, that's just going to contribute a factor of 4, just the length of this interval from 0 to 4. So we're going to get a 16 out front. And then here's the integral of this quantity, 1 minus cos 2u all over 2. So when all is said and done, we get a value of 4 pi for the flux. Okay, and again, as I said at the beginning, we are observing positive flux because our vector field F here is pointing in the direction that's considered positive flow, right? Because of this choice of orientation where normal vectors point in the general direction of the positive y-axis. All right, cool. Well, that's going to do it. Thanks so much.